Hello everyone. So far this chapter we have been working with solving systems of linear equations, and so today we're going to switch over and now we're going to be talking about solving systems of linear inequalities. So linear inequalities are actually something you guys have worked with in the past. This is actually what we ended with at the end of last semester. So we're going to do one example to review how we graph a linear inequality, and then we'll start talking about how we deal with systems. So, for our first example, we're going to graph this inequality. So what you'll notice here is now it doesn't say y equals anymore. We have this inequality symbol. So here's what we need to remember. If you think back, the first decision we had to make when we were graphing these inequalities was whether the line we draw is going to be solid or dotted. So if you remember back, we said if our symbol was greater than or less than, we were going to draw a dotted line. If our symbol is greater than or equal to or less than or equal to, we said we'd draw a solid line. So in this case, since I'm strictly greater, we know we're going to have a dotted line. Now, the other thing we had to think about was where we shade. And so we had said if our inequality symbol was greater than or equal to, that we were going to shade above the line. And if it was less than or equal to, we were going to shade below the line. So in our case, since it's greater than, when we get there, we're going to be shading above. So here's what we did. We started this just like it was a normal line. So we look at our equation, we think about our mx plus b. So what I notice here is that my b, my y-intercept, is a -3. So I'm going to go down 3. Now my slope is a +4, which means I have a rise of 4 and a run of 1. So 1, 2, 3, 4, and over to the right 1. So now I'm going to connect those points, but again, since I'm strictly greater than, I'm going to connect them and I'm going to use a dotted line. So here I'm going to make sure I have a dotted line. And now, since it was greater than, we're going to shade above, which means if I look on my line, I should be shading up. So I would shade everything here in this blue area. And remember, the idea here was that all of the points in this blue area are solutions to that inequality. So any point in this blue area would make that inequality true. So that was graphing just basic inequalities. So now we're going to look at systems of inequalities. So when we have a system of inequalities, we want to find all the points that make both inequalities true. So just like with systems of equations, that solution has to work for both inequalities. So it would be impossible to list all of the points, so we usually graph and shade instead. So for example, we could have never listed all of the points that were solutions of this inequality, so we use that shading to represent the solutions. Now, we're going to graph each line separately, and then we're going to look for where their shaded sections overlap. Any points that are in that overlapping shaded area are going to be our solutions. All right, so let's see how this all works. So for my problem down here, it's asking us to graph the system, and then we're going to shade that area of intersection. So I've got two lines, so I'm going to do one in blue here. So in this case, my y-intercept is a -2. My slope is a -1, which I know is the same as -1 over 1. So I'm going to go down 1 and then to the right 1, like this. Now, looking at this line, I know because it's strictly greater than, that it's going to be a dotted line. So let's go ahead and do that. So I have my dotted line, and then because it's greater than, I'm going to shade above that line. So I'm going to shade everything up here. Okay, so there's my first inequality. So now I'm going to do my second one. So in this case, my y-intercept is a positive 6, and my slope is 3, which I know is the same as 3 over 1. Now obviously if I go up 3, I'm going to go off the graph. I know this is the same as a negative 3 over a negative 1, which tells me I'm going to go down 3 and then to the left 1. So down 3, left 1. There's a few points. Now, since this is less than or equal to, we're going to have a solid line. So I'm going to shade this, or excuse me, I'm going to connect these points with a solid line. And then it's less than or equal to, so I'm going to shade below. So everything below is going to be down here. So I'm shading everything below. Now you can notice in this area here, here's where my orange and my blue are overlapping. So that is going to be the area of intersection. So I'm going to go ahead and just shade in this overlapping area. So these points, all of these points in this blue area, are points that would make both of my inequalities true. And so that's the idea here, is you're looking for where those shaded areas overlap. All right, let's see. Let's flip to the next page. Yeah, and we've got a couple more examples. So we'll do one of these examples, and then we'll save the next one for class. Now, in number 2, we have to be a little careful because I noticed for my first equation, it's not actually in slope-intercept form yet because y isn't by itself. So we've got to do a little work here before we can graph. So my equation is x minus y is greater than or equal to 4, and I know my job is to get y all the way by itself. So the first thing I'm going to do is subtract x from both sides. So I'm left with a negative y is greater than or equal to negative x plus 4. Now, to get y by itself, I need to divide by a negative 1. And I'm going to divide everything by a negative 1. Now, something we need to remember is when we multiply or divide by a negative, we said we needed to flip that inequality symbol. So instead of greater than or equal to, this is going to become y is less than or equal to x minus 4. Okay, so my rearranged equation is y is less than or equal to x minus 4. So if I graph that one first, I have a y-intercept that's negative 4. My slope is 1, so it's up 1 over 1. Since it's less than or equal to, I'm going to use a solid line here. And then now, because I'm less than or equal to, I am going to shade below that line. So just this portion of the graph. All right, now let's look at our second line. Now here we have to be careful. This is y is greater than 2. Here's where we have to remember our Vux-Hoy trick. Since this is y, we know that's Hoy, which tells me I have a horizontal line through y equals 2. So that's going to look like this. And so now I have y is greater than 2. So that tells me that I'm going to shade everything above this line. So this one's actually a little tricky to see, and it would probably be helpful if this were extended more. But now I can see here, really all I have to shade in, if this were extended, is this corner of the graph right here. So again, the basic idea here is we're just graphing our linear inequalities and we're looking for where those shaded sections intersect. So like I said, we'll do example 3 the next time we're in class because that's a little more complicated with 3 inequalities. But for right now, hopefully this gives you enough to go on. So make sure you've got good complete notes and I will see you back in class. Thanks.